Hello everyone, welcome back to the series. Today's topic is wallets, probably the single most misunderstood piece of the whole blockchain stack. By the end of the video, you will know exactly what a wallet is doing under the hood, the difference between hot and cold storage, and why your seed phrase is one thing you can never lose. Let's see it. A wallet doesn't hold coins. Let's clear up the biggest misconception first. People think of a wallet like a physical purse holding their coins. That's not what's happening. Your coins are entries on the blockchain ledger. They never move into an app. What a wallet actually stores is your private key, and it uses that key to prove ownership and sign transaction when you want to spend. Now we are going to see what is public key and private key. Every wallet rests on pair of keys. The private key is a huge random number. Keep this secret always. From it, using elliptic curve math, we derive a public key, which is safe to share. That's what becomes your receiving address. The relationship is one directional. You can go from private to public easily, but there is no way to reverse a public key back into the private key. That made it. Private key proves the ownership of an address and signs the transaction, must never be shared. If you lost the private key, it will be a permanent loss of your funds. It will be 256 bits long. It will be a secret number, right? Now it is an one-way function. Like already we have said that in public key, it is derived from private key. It is safe to share openly. It is used to receive the funds. We cannot reverse to find a private key. Then this public key will be your wallet address. Now we are going to see about how your address is going to build. Here is that the derivation as a pipeline. Start with a random private key, run it through elliptic curve multiplication to get a public key. Then hash that public key. SHA-256 and RIP uh, RIP emd 160 for Bitcoin, keycag 256 for Ethereum, and encode the result into the address format you actually see and share. Every arrow only runs forward, it won't come backward. This is why wallet address is safe to publish but a private key never. Now I think you know how the private key and public key are related and how public is derived from the private key. Now we are going to separate custodial versus non-custodial. Wallets also differ in who is actually holding the private key. A custodial wallet, like the wallet built into a typical exchange, it means a third party holds the key for you. It's convenient. Recovery is easy, but you are trusting their security and their solvency. A non custodial wallet means you hold the key yourself, full ownership, but also full responsibility. There is a no customer support line to call if you lose it. For example, custodial is a exchange hosted wallets, non custodial is a self hosted wallet apps. Now we are going to see about hot wallets versus cold wallets. Separately from that, wallets are hot or cold depending on internet exposure. Hot wallets, mobile apps, browser extensions stay connected, which makes them fast and convenient, but also exposed to malware and phishing. Cold wallets keep the private key offline entirely, using hardware devices or even paper. Slower to use but dramatically more resistant to remove attacks. Most people use both. Hot for spending money, cold for savings. Hot wallet is also called as a software wallet, and cold wallet is also called as hardware wallet. Now we are going to see about types of wallets. That gives us four common wallet types in practice: desktop, mobile apps are hot and software based. Web and browser wallets are also hot and often custodial. Hardware wallets are dedicated offline devices. Ledger, Trezor are common examples, and they are cold. And paper wallets, where you are literally write or print your keys, are the simplest form of the cold storage. In this, H means hot storage, C means cold storage. Now we are going to see about deterministic wallets. Underneath any of these types, wallets also differ in how they generate keys. A deterministic wallet generates every key from a single starting value. It means the seed. Using a fixed algorithm, restore that one seed on any device, and the entire wallet, every key it ever held, comes back with it. There are two flavors: a simple deterministic design and the tree structured hierarchical deterministic wallet, which we will get into shortly. Next is non-deterministic wallets. The alternative is non-deterministic wallet, sometimes called just a bunch of keys or JBOK. Here, every private key is generated independently and randomly. There is no mathematical link between one key and the next. This was how early Bitcoin core wallets worked. Before that BIP32 standard existed. The catch is backup. You have to separately back up every single key. Miss one and those specific funds are gone for good. It's mostly depreciated today in favor of deterministic designs. Which now we are going to see about seed phrase. Whichever type you use, it typically reduces to one seed phrase, a sequence of 12 or 24 ordinary words, standardized under BIP 39. This single phrase can regenerate every key your wallet controls. Write it down offline on paper or engraved metal, never as a photo or a text file on a connected device. Anyone who has these words owns everything in the wallet. What if you lose them? Then funds are gone permanently. No password reset existed. Hierarchical deterministic wallets. That single seed is powerful because of hierarchical deterministic wallets. HT wallets for short. This is a structured version of deterministic wallet standardized across three BIPs. BIP 32 defines the tree structure itself. BIP 39 gives us the mnemonic seed phrase, and BIP 44 standardizes derivation paths like M440000. So any wallet software can find the same accounts from the same seed. From one seed, the wallet derives multiple accounts and multiple addresses under each, all the reproducible from that starting point. So you only ever back up the phrase once. Next is hardware wallets. One of the best places to keep the key material is a hardware wallet. It is a small physical device built for exactly this. It generates and stores private key inside a secure element chip, and critically that never leaves the device, not even to the computer it's plugged into. When you send a transaction, the signing happens on device itself. Only the already signed transaction goes back out. It also requires a physical button pressed to confirm, which makes it immune to remote malware even on a compromised computer. Ledger, Trezor, and Keystone are the common examples. Now we are going to see about wallet security checklist. Let's turn that into a practical checklist. Never share your private key or seed phrase with anyone for any reason. Keep the seed phrase offline. Use a hardware wallet once your holdings are significant. Always double check the destination address before sending. Malware is known to swap clipboard addresses. Add a pin or passphrase on the top of the seed for extra protection. And be skeptical of anyone reaching out asking you to verify your wallet by handing over your keys. That's always a scam. Now we are going to see about recap. Wallet hold keys, not coins. Your private key derives a public address through a one-way chain. Custodial versus non-custodial is about who holds the key. Hot versus cold is about internet exposure. Deterministic wallets regenerate everything from one side, while non-deterministic wallets need every day backed up separately. And HD wallets held on hardware devices for maximum safety, or how that seed become an entire tree of accounts. Next time we'll go and see about the smart contracts and paid networks. Thank you.